Alright, moving on here to Unit 5. Alright, so these ones just can kind of talk through a bit before we get into the real, meat and bones of this unit. So, first thing I do is kind of look in different ways we could express what's known as a relation. So a relation is a set of ordered pairs. So thinking of them as x comma y. So just a bunch of x's and y's. So here is what we have. We have this nice big graph. So let's think about the relation. So let's just go alphabetical. A is -2, comma 2. B is 4, comma 3. C, -4, -1. And we can go on and follow that same pattern, getting through our points. Is a table, it would just be listed in this way. So A, B, C, and filling in the rest of our points. So not a whole lot of crazy new stuff. The domain. This is where we would list all of the x values. So I would write out the points. -2, 4, -4, as well as the rest. The range lists all the y values. So I'd list out my y's, 2, 3, -1, all the way through. Now, a mapping. This is going to be a little different. So I'm going to think about the elements in my domain, the x's, and how they go with my range, the y's. So let's go back up here and just finish our table. Then we'll use that to complete our mapping. So D is 3, comma -2. E, 1, 1. And F, -5, 4. So what we're going to do is to create our mapping is put all these numbers from starting at the smallest at the top and then go in our next column and do the same thing. So in the least to greatest order, -5, -4. -2, 1, 3, 4. Doing the same with my y's. So -2, -1, 1, 2, 3, 4. And the last step here is just kind of drawing some arrows to see what connects to what. -5 goes to 4. -4 goes with -1. Let's see here. -2 goes to 2. One goes to 1. 3 to -2. Oops. And 4 goes with 3. So this illustrates how each element of the domain is paired with an element in the range. Here, kind of the same thing, just drawn a little bit different. So we'll just go ahead and I'll show you how to write the first few points here. So these go together, these, so on and so forth. So I'd have 2002, 305. These squiggly things on the end are just braces. They just kind of group everything together. And then our last point here, again, you'd write those in yourselves, but for the sake of time, just helping you guys get the big idea. And a braces at the end. Again, domain, list all your x's, range, list all y's. There's no need to repeat if a value happens to show more than once. You can just write it once. And that's going to be it for our notes 1. From here, you can move on to 2 and go ahead and work through those 3 problems for practice. From here, we're going to move on to 3 for some more notes. Okay, here's when we use a qualitative graph to describe a situation. Alright, a little bit of vocab. Independent versus dependent. So, the independent is the one thing that is measured. Or it's what we're kind of counting by. On a graph, it's the x-axis. The dependent is the outcome, or what we're kind of looking at the end. It depends on what you change. So you could also think of independent as the thing that's changing. Let's go with changed instead of measured. On a graph, it's the y-axis. So here, the independent causes the dependent to change. So for number 1 here, the temperature of the water was measured at different depths of the ocean. So we're not controlling the depths of the ocean. So depth of the ocean would be our independent, and we're seeing how the temperature changes. The score on the final exam, and the number of hours the student studied. So we're checking the different number of hours, and we're seeing how it affects or changes the score on the final. Alright. So, increasing functions essentially means from left to right, we're going up. So looking at these 2 points here, it's definitely going up. Decreasing, we look at these 2 points. Between them from left to right, it's going down. Constant just means between any 2 points, it's not going up or down, it's a flat line. Alright, so looking at a distance-time graph. The horizontal axis, this is our x-axis, and the vertical, our y-axis. So the horizontal here represents, if we look, time in seconds. The vertical, or the y-axis, distance in meters. So on the graph, a horizontal line represents, we see it here, it's stationary, it's not moving. So anytime we see a flat line in a distance versus time graph, that means the object didn't move. So no matter how much time passes, the distance hasn't changed. So for our sloped lines, that means that they're not flat. If it's rising from left to right, as in going up, it's getting farther from the beginning. We can always think of this 0, 0, the origin. Terrible looking. Let's rewrite that. Origin as our starting point. So it's like a board game. It's where you begin. So if we're falling from left to right, I mean we're going downwards or a negative slope, getting closer to the starting point. So graph 1, let's take a look at our blue here. So here, it just seems to be going up, and up and up and up. So, going away. Graph 2, we'll say that's the red one. This one's got 3 distinct parts. So it starts going away, stops moving, and then comes back to start. So goes away, stops, goes back to start. And again, the start would represent that distance of 0. So the x-axis represents like your home base. Independent and dependent. Independent here, our x-axis, that's time. Dependent, our y-axis, our distance. Okay, so distance traveled after 2 seconds. Again, we'll keep the same order. Blue for graph 1, red for graph 2. So after 2 seconds, the blue traveled a distance of, let's see, 2 seconds, 10 meters. The red, a distance of 4 meters. The speed, well, let's see. We know that velocity is distance divided by time. And again, that's a note card item. So, for here I went 10 meters divided by 2, so my velocity is 5 meters a second. The red, I went 4 meters in 2 seconds, so it would be 2 meters a second. Again, definitely rock that one on the note card. So what I want you guys to do here to finish up notes 3 is go ahead and try out this exit path. So match up those 4 descriptions with the graphs that go with them. What you'll be doing next is working through homework 4. So you're trying all of these problems. Once you've completed that, you'll move on to 5 for some more notes. Alright, let's take a look here at 5. So, a function is a relation in which each element of the domain, or axis, is paired with exactly one element of the range, or our y's. So again, you can kind of look through how to review here. Let's go back to notes 1, or practice 2, there, the number 2 homework, on how to go ahead and write out those relations from that. And now, let's see if it's a function. Okay, well here, I see 2 arrows coming out of my 1. That means I have -1 going to 4, and -1 going to 5. Well, that means -1 goes to 2 things, so not a function. Here, each x goes to only 1 y. None of these have 2 arrows, so yes, function. Now let's see. For these ones, I'm looking at the number 2. Let's see if it comes up again. No. No. What about the 4? No. 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 The 3? No, no. 5? No. So since each of my x's, I only see them once, yes, it's a function. Let's check here. Okay, so I'm looking at my 6. No, no. Notice I'm only looking at the x's now. Wait a minute. 6 shows up twice, and these numbers are different. Therefore, not a function. A table. Well, these numbers are all different, so I'm good. Let's see. I have 5 here, and I have another 5. So this one's yes. This one's no. Yes, it's a function. No, it's not. With a graph, the vertical line test means if I draw a vertical line, I can't hit 2 points. I definitely hit 2 points here. Nope, not a function. Here, if I look, no matter where I draw a vertical line, I'm never going to hit the line twice. Yes, this one is a function. From here, we are good on these notes. So, review those. And what I got you guys to do is work through all of the problems here on quiz practice 6. This is a great type of mid-unit review. Once you've completed it, we'll go on to 7 for some more notes. Alright, so, functional notation. Instead of this, now it's this. So basically, instead of y, we write f of x. That's the key idea, functional notation. So that's what we're going to see here in this unit. So, basically, wherever you see y, instead we're going to write this nice term here, f parentheses x parentheses. Okay, what we're going to do now is knock out a few of these together. So, let's see here. F of 3. Let's take f. That's 2x minus 5. And this says plug in 3. Calculator. My answer is 1. Let's try g of negative 4. Well, here's g. I'm getting that from up here, just like I got f. Key idea here, whenever you plug in a number, put parentheses around it. At this point, it's typing in the calculator. So this would be, let's see, 16 plus 12. Here we should get 38. Let me just check that real quick. Yep, we're good to go. Sorry, my calculator batteries are running. And again, GeoGebra, perfect for this. Type it in just like it looks, spits out your answer. Alright, moving down a bit. Graphically, well, let's see, negative 1, that means x is negative 1, so I'm going up, that's that point, so it'd be 1. H of 2, well, at 2, looks like I'm up here, that means my y is 4. At 0, still at 0. At 1, right there, also 1. Let's go ahead and skip that. Again, key idea, put the parentheses like I showed you about. And I think we're good here. So, using these notes, let's move on here to 8. And you guys are going to work on all these problems on here. Once you've completed that, let's go ahead on to notes 9 for some more practice. Alright, for notes 9, we're going to do a little bit more with evaluating these functions. So here's an example where we know what f of x is, and another thing that it's equal to. So let's think, well, f of x is the same as f of x. So that means that this must be equal to this. I'm about to do some algebraic solving, so again, if you want to go back and get a refresher on that, check out Unit 2. Moving on. Similar type of problem here, so I'd have distribute again, if it's moving a little quick for you, go ahead and pause, or again, as I suggested earlier, going back to Unit 2 is our big unit for showing the work and explaining our way through these equations. Alright, looking at the graph here, so here notice we're given our y values. This time we're finding the x that goes with them. So at a y value of 4, I'm either getting this one or this one. So I could either have negative or positive 2. So negative 2, positive 2. At 0, well there I'm only getting 1. I'm looking at my y-axis here, so that one's just 0. And for 1, we're getting either negative or positive 1. From here, let's go ahead and complete all these problems on here, as well as, well, that's good for this homework. Let's just do all the problems on this. Once you've completed that, we're going to go ahead on to number 10 for some more notes. Alright, so a little bit of vocab here. Interpolation versus extrapolation. Interpolation, data on graph. Extrapolation, data not on graph. For extrapolation, we need an equation. So let's try to make that a little more sensible with some examples. Alright, so we're going to we're going to evaluate these points, and then decide if it's interpolation, which I'm going to label as I, or extrapolation, which I'm just going to call E. Key idea here is these first two letters, IN. That means it's in the graph. Extra. Well, extra doesn't sound like it's very easy to find, right? So that's off the graph. Okay. F of 3. Well, that means my x is 3. There's my answer. That's f of 3. Which looks like, well, halfway between 30 and 40, that's 35. If f of x is 40, well, that means here's my f of x, and here's my x's. 40 is on there. So, going over, well, that would mean here, it's at this point, so x would be 4. Find f if x is 42.5. Well, that would be halfway between these, because that's halfway between 45 and 40. So here, if I go over, well, it's halfway between 4 and 5, so that's 4.5. F of 14. Wait a minute. That's not even close. 10 is way smaller than 14. Time to use my equation. So I'm plugging in 14 for my x. So that gives me 110. I lied. That's definitely not 110. Let's see, 50 plus 20 is 70. That's going to be 90. Find x is f of x is 50. Okay, well it's 50. That would give me here, x is 6. F of x is 90. Wait a minute. Not on my graph, right? So that means I got 90 for f of x is equal to 5x plus 20. Alright, so let's think. Interpolation was I. That means it's in my graph, or on my graph. This one, that was in the graph. 40 on the graph. This one, even though it's kind of ugly, it was there. That's in the graph. I see an equation. That's extra. Extrapolation. 50 in the graph. Equation. That's extra. Extrapolation. So, let's go ahead and take a look here. We'll do one more of these together. Let's go ahead and take a look at this one right here. So, it's springtime. You want to prepare your garden for planting, so you visit your local hardware store. Blah, 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 blah. Feel free to read on your own. You guys are big. Here's my equation. So x is saying the number of hours we spend, and our y-axis here, our f of x, is the cost in dollars. And here's my x-axis. Question 1. And again, we're going to go with that I for interpolation, E for extrapolation. If you have no money, how many hours can you rent a machine? If I have no money, no dollars, so that's here. Looks like I can't rent a machine at all, does it? Right, because when you have no money, you ain't getting a machine. None. Or not at all. If you have $50, how long? Oh, and this one would also be interpolation, because it's technically on a graph. How long can I rent a machine for? So $50, that's, whoa, that's not on my graph. So I can tell you already it's extrapolation. And I'm going to need my equation. So f of x would be 50. Doing a little bit of solving here. That would give me x is equal to 11.25. So I could rent it for about 11.5 hours. How much will it cost for 3 hours? Well, let's see. 3 is on my graph, so it's interpolation. And up here, bingo. What's between 18 and 16? 17. Moving on. How much will it cost for 15? Not on there. Let's extrapolate. So, f of 15 60 plus 5, it gives me 65. So it's going to cost me $65 to rent it for that long. Cost was 57, not on my graph. Let's extrapolate. A little bit of calculator work there. We find we get 13 hours. So, for 10, looks like we're pretty good here. So what I'd like you to do is let's go ahead and take a look at 11. Actually, you know what? We're going to skip 11 altogether. What I want you to do is finish all of the problems on 10. So about 3 more. Once you finish that up, again, totally skip 11. And we're going to move on to 12 for some more notes. Alright, so our last bit of notes here for Unit 5. Here we're working on adding and subtracting functions. So, let's take a look here. Here we got f of x and g of x. Well, f plus g of x, that's the way it's read, f plus g, and they're both of x, is the same as saying f of x plus g of x. Now to do this, let's go ahead and plug some stuff in. So f of x is 4x squared plus 3x minus 1. I'm adding g of x, 6x minus 2. Our like terms, well, I got only one thing that's squared, so I can't combine there. 3x and 6x, those both have just an x, so I combine them. Negative 1 minus 2, or minus 1 minus 2, however you want to think of it, they're like terms, so I get a minus 3. Subtracting, tad bit different here. So this is going to be f of x staying the same, and we're going to minus g of x. So basically that minus sign, I could think of it like this. Plus negative 1 times g of x. That's a note card item. I would suggest you definitely put that on. So here, let's go ahead and plug in. So f of x stays the same. And then I'm going to use this part. So plus negative 1 g of x. If we go ahead now and distribute. So the first one's staying the same. Now, negative 1 times 6 minus 6x. Negative 1 times 2 minus 2. This is the only thing that's squared. So it just comes on down. These both have an x. So 3 minus 6, negative 3x. That's a number. That's a number. Negative 1 minus 2, negative 3. From there, what I would like to have you guys do is go ahead and complete these 2 problems, as well as all of the problems here. If you can do that, you are going to be in great shape for this test. Once you've completed that, your last assignment here is to complete the review. If you can do all the problems on this and you've checked them with me, you are going to be in great shape for passing this Unit 5 exam. Best of luck.